Hello everyone. In this video, we will do an example for expectation and variance of a continuous random variable. So a continuous random variable x is given with the PDF, which is this function. Now the question is asking for expectation and variance. Well, let me first quickly review what are these notions for continuous random variables, and then we go from there. So let x be a continuous with the function with the PDF function f. Then expectation or expected value or mean of this random variable, sometimes we denote it by mu, this guy, is given by this integral x times f of x dx. And this must go from negative infinity to plus infinity. Well, you may say that what do you mean by infinity, negative infinity, plus infinity limits for integral? Well, usually what we will have is that f PDF for this course, PDF function is 0 outside an interval a to b. So outside a to b, it is 0. Then what it means is that you can turn that integral into three integrals, from negative infinity to a, from a to b, and from b to plus infinity. xf of x, xf of x, and xf of x. But since we know that it is 0 outside this interval, so that must be 0, that must be 0. The only part remains is just a regular integral on an interval. So don't worry about the notation that you see here, but you need to know that for this course, we will deal with the cases that the PDF outside an interval is 0. And again, like the discrete version, e of x, you have to look at this thing as if I have f of x, e of x squared, what will happen? So this will be, instead of x there, you will put x squared f of x dx. If this is 3, you will go with 3. If any function of x you put there, this will mean that you integrate f of x times that function from negative infinity to plus infinity. Well, if you know that, then the variance is defined as before. This is e of x minus mu squared, which means that you have to integrate from negative infinity to plus infinity, x minus mu. So x minus mu is a function squared times f of x dx. And similar to what we had before, alternatively, variance can be calculated also by this formula, that this is e of x squared minus mu squared. Okay, again, three formulas. That's e of x, this is variance of x, and then the variance of x can be calculated also this way as well. Let's do the example now. So expectation or expected value or mu of this random variable is integral from negative infinity to plus infinity of x times f of x dx. But this is piecewise defined. I can separate it into three pieces, from negative infinity to 0, from 0 to 1, and from 1 to infinity. And on each one of these guys, I will do the same integration. But I know that outside 0, 1, f of x is 0. So those two integrals will go away. The only remaining part is going to be the integral over 0, 1, on which the function is defined as 3x squared. So that integral is now integral of 3x cubed from 0 to 1. Fundamental theorem of calculus. And then that is 3 over 4, 1 to the power 4 minus 3 over 4, 0 to the power 4. So that will give me 3 over 4. So the mean expectation or expected value of this random variable is 3 over 4. How about variance? Let's use both cases. So I'll go from negative infinity to plus infinity of x minus mu is there squared times f of x dx. With a similar argument that we used above, this can be turned into integral 0 to 1 of the function on that interval is 3x squared. Let me expand this piece. First one is squared minus 2 times the second one times first one. So this will be 3 over 2x plus the second one cube. Second one squared. So 9 over 16. And then we multiply those ones. So this is what? 3x to the power 4 minus 309 over 2x cubed plus 27 over 16x squared dx. I'm going from 0 to 1. Fundamental theorem of calculus, I need this one, I need this one, and I need, so these are antiderivative of each term. If you plug in 1, the only remaining part will be the coefficients, because 1 to the power any number is 1. The other part will give us completely 0. So the variance, now common denominator, this is, okay, I can put 80 there as common denominator, times that, this is 48 minus 80 divided by 8 is 10, this is 90, plus 545, yes. Oh, that's nice. 93 minus 9 is 3 over 80. So the variance with the regular formula is that. Well, or we can use variance of x is equal to e x squared minus mu squared. And I know what is mu. I have to find what is e x squared. So go from negative infinity to plus infinity x squared times f of x dx. But our PDF is only non-zero on the interval 0, 1, and it is given by 3x squared times x squared. So this is integral of 3x4 dx, and this is 3 over 5 x to the power 5. Go from 0 to 1, which gives me just 3 over 5. Then the variance of x is going to be 3 over 5 minus 3 over 4 squared. Mu is 3 over 4. Yes, we just found it up there. Yeah. And that will give me, yes, okay, so let me just write these one. 3 over 5 minus 9 over 16. This is, again, common denominator is 80. This is 48 minus 45, which is 3 over 80. And you see that this is exactly equal to, so either of these ones you use, you should get the same value. Okay.